Hello and welcome to this episode of Math with Martinez. We are in our first episode in our unit on trigonometric functions, and we are looking at degrees, radians, and coterminal angles today. The goal of our learning is to be able to represent angles in radians or degrees based on the concept of rotation, and then find the measure of our reference angles and angles when they are in standard position. So let's go ahead and get started with a bit of an introduction to what exactly are angles when they're in a coordinate plane. So an angle on the coordinate plane would be considered in standard form. Let's highlight that. It's going to be in what we call standard form when the vertex is on the origin and one ray lays on that positive x-axis. So you can see that pictured right over here. Notice that the vertex is going to be highlighted right here at the center at the origin. And then it has a ray on the positive x-axis. Let's go ahead and highlight that. The ray on the positive x-axis, which would be right here, that is called the initial side. That's called the initial side. And the other ray, which I'm going to highlight in red, the other ray is called the terminal side. Now, if we are rotating like you see here in this picture counterclockwise, let's go ahead and make a note of what that looks like. Counterclockwise rotations are when you're rotating opposite of what a clock would be. So counterclockwise rotations result in what are positive angles. And what that would be, just to kind of clarify more, let me make a little note here. That's going up and around from the x-axis. Or we would call that the initial side. That is going to give us an angle that would be positive, whereas if instead you go down and around, which is clockwise, that is going to be a negative angle measure. Okay, so that gives you kind of an idea of how angles can be transposed or placed over a coordinate plane, and then we're able to actually measure them in our coordinate plane. And when we're working in our coordinate plane, the most common unit of measure whenever we're dealing with angles is the degree. And it's denoted with a little circle like that. Now the degree is equivalent to 1/360th of a full rotation. There are a total of 360 in a full rotation, so each degree is 1 out of the 360. And you can see that pictured right over here. And we have the Babylonians to thank for working in a system that is a 360-degree rotation. But I digress. Now, what we're going to do here is sketch an angle in standard form with the given measures. So what we need to know is where we're starting, and then if we're rotating positively or negatively. And remember here that a rotation up unto this point would be 90 degrees. If we do a half rotation, that's 180. If we go 3/4 of a circle, that's 270, and all the way around is 360. So that kind of helps you to break your coordinate plane into different quadrants and identify on those special quadrant angles exactly what they are. So in this first example, if we're stopping at 65 degrees, well, 65 degrees is going to be in this region here between 0 and 90. I'm going to sketch that out. It's going to be a little bit more than halfway, so maybe it looks something like this. And I'm rotating upward from my terminal side. Rotating up from my terminal side because this is a positive angle. Now the next one, 320. 320 is going to be somewhere in this fourth quadrant because it's between 270 and 360. It's going to put us right about here. Okay, now 415. 415, you might be thinking, what? What is that? Well, that's more than one rotation, right? That's going to take us one rotation, which is 360, and then a little bit more. Let's see how much would be left there. Grab your calculator. If you take 415 and subtract a full rotation from it, that means that we've gone a full rotation and 55 degrees more. So I've gone all the way around once and then a little bit more than halfway. Let me back that down a little bit, maybe right about there. So that is going to represent my full rotation, positive rotation, and terminating 55 degrees after I've gone around one full time. Now take a look here. These next 3 examples are negative angle rotations. So you're kind of thinking in reverse here. What we've done here is gone negative 140. Now, what exactly does that mean? That means that I will have gone 90 degrees, but in this negative direction. So I'm going down. And how much more? So if I take 140 and subtract 90 from it, how much more is that? 50 degrees. So I'm going to go 90 degrees and then a little bit more than halfway over here. Maybe it looks something about like that. Negative 15 degrees is going to mean that I just go down a little bit. You know, I haven't really rotated much. Maybe about like that. And negative 210, well, that's a little bit more than 180. How much more than 180? Let's think about that. 210 minus 180, how much does that leave us with? 30 degrees past that. So I'll go half a rotation and then about 30 degrees more. So maybe that puts our sketch right about here. Something like that. It might be a little bit too high. Let me. Yeah, I like that better. Okay, so there you go, guys. That is sketching angles in standard form in our coordinate plane, making sure that the vertex of our angle is at the origin for every single one of these. All their vertices are at the origin. And then we've got our initial side being the x-axis. That's where we each time we're starting our rotation from, and then ending with the terminal side this many degrees from our initial side. That's degree measure, but that is actually not the only measure that we can work with. Radians is another unit of angle measured, and it's based on arc length, which actually comes in super handy. 1 radian is defined as the measure of the angle formed when your radius is equivalent to the length of your intercepted arc. So what does that mean? It means that this distance right here, the radius, is the same distance as the arc. That is an angle of 1 radian. The circumference of a circle is defined as 2 pi r, which means, ladies and gentlemen, that 360 degrees is 2 pi radians. And if you think of half of that, half of a circle is 180, well then half of 2 pi is just pi radians. So when we're converting from degrees to radians, you're going to take your degree measure and multiply it by this little unit conversion where you have pi radians over 180 degrees. And if instead what you're working with are radians and you want to go to degrees, then you'd multiply your radians by 180 degrees over pi radians. So those are our conversions that we're going to need when we're going between these 2 units of measure. The last big idea that I want to introduce to you here are the concept entitled coterminal angles. Maybe you noticed back over here, we were rotating one way, either positive or negative, depending on the angle. And I marked that with the little angle mark, that little curve mark like you see here. But whenever you have an angle in standard position, that terminal side, you could either rotate positively to get there or negatively to get there. And those 2 angles that terminate in the same spot are called coterminal angles. So in this illustration here, if we rotate positively and terminate right at our y-axis, that positive y-axis, that's 90 degrees or pi over 2 radians. And similarly, if instead you rotate negatively, you're going to end up in the same place if you rotate negative 270 degrees or negative 3 pi over 2 radians. So what we're going to do here is we're going to determine whether the 2 angles are coterminal to one another. Let's go ahead and see if this is true. All right, let's go ahead and see. How do we determine if they're coterminal? Well, check this out. Let's take this. 360 degrees, if you're working with 360 degrees, and you subtract that negative angle, 270, what does that put you at? 90 degrees. That's why the 90-degree angle is coterminal with 270. So let's see if I take my full rotation and take away from it then that negative rotation, that should give me a positive coterminal angle. All right, so let's see. Down here, if we have 360 and we take away that negative angle, what does that give us? What is the difference there? What is 360 minus 55? 360 minus 55? That is 305. And 305 is the other angle that we had. So yep, those two are coterminal with one another. Let's check this next one. Are these coterminal? What do you guys think? Let me know. Try this one on your own and then let me know. Are they yes or no? Coterminal or not? So take your full rotation, which is 360, and then take away from that your negative rotation, which is the 170. And the difference there, the difference between those two, when you take, when you take 360 and subtract from that 170, that would be 190, 190. Which means saying that 30 is coterminal with that? No, it would be 190. That would be the coterminal angle that would end at the same spot as rotating negative 170 degrees. So this is a no, not coterminal. All right, now let's look here at these. In the same way we did here, we're going to take, even though we're working with radians, we're going to work with a full rotation, which would be a full rotation in radians is 2 pi. And then we're going to take away the negative rotation from that. Now, it is helpful to go ahead and think about this as having a denominator of 1. Your 2 pi has a denominator of 1. To be able to subtract these, you're going to want to work in units that have the same denominator. So what I can do is I can take this value and multiply it top and bottom by 4, so that what I'm working with is 8 pi over 4, which does simplify to 2 pi, but now I can go ahead and think about these values here. If you take 8 pi and subtract 9 pi from it, how much does that leave you with? That leaves you with a negative pi over 4. So are these going to be coterminal? Is that matching? No, it's not. It's not. It seems close, but not quite. All right, and what about this next one? Are these coterminal? Well, let's check and see. Take your full rotation. Full rotation is 2 pi. A full rotation would be 2 pi. And take away that negative radian measure from it. Get common denominators to see. And that gives you 4 pi over 2. Subtract 5 pi over 2 from that. And what do we have? What does that give us? Well, that's going to give us a negative pi over 2. So again, no, not matching what we see there. So there you guys have it. We have seen what it is to sketch angles in standard form, and whether that is in degree or radian measure. And we also are looking at being able to identify those coterminal angles, those angles that are ending at the same terminal side. If you guys had any questions about this video, please take a moment to share those now. And until next time, stay fired up.